Okay, we're going to continue on with the Chapter 6 homework with problem number 3. We've got that the surface of a saturated clay deposit is located permanently below a body of water. Sounds a bit like problem 2. But then we've got lab tests that have told us that the average natural water content of the clay is 47%, and the specific gravity of the solid material is 2.74. We want to find the effective stress at a depth of 37 feet below the top of the clay layer. But we're going to use this hint to use a phase diagram worksheet to find gamma clay first and assume the volume of the solids is 1 cubic foot. So this is a nice problem. It puts things together, the phase diagram that we worked on before, and we're also going to find vertical effective stress. So first things first, let's do the phase diagram. And I started filling that out already with my default values that the weight of air is 0, gamma air is 0, and that gamma water is 62.4 pounds per cubic foot. And then I was also given this volume of solids. I went ahead and found the gamma of solids next because I knew the specific gravity that was given to me as 2.74. So I know if I multiply that by 62.4, I can get my gamma solids. When I went ahead and did that math, 2.74 times 62.4. Yeah, I got a number like this. If I wanted to round it to the tenths place, I would have to go up to the nearest whole number. So I went up to 171 there for my gamma solids and put that in for number 6. All right, from here I can see I've got everything in this row except for my weight of the solids. So I'll just go straight across to figure that out because volume of solids times gamma of solids is going to give me weight of the solids. So I'll make that my number 7, that my weight of solids is equal to volume of solids times gamma solids. In that case, it's just 171. I guess I'll write that pounds rather than P. And then I'm going to go ahead and use that water content that I was given because I know that's going to give me a relationship between the weight of the water and the weight of the solids. So I'll do that for number 8. My water content, remember, is equal to that ratio of weight of the water over weight of the solids. I want to find the weight of the water now because I know the weight of the solids. So I'm going to take my water content and multiply it by the weight of the solids. And they said that natural clay was 0.47 was the natural water content. And then I'll multiply that by the 171 pounds that I just found. So put that into the calculator, 0.47 times 171, and I get 80.37. And I'll go ahead and round that to 80.4. And we'll put that in for number 8. Well, I can see as I look at my phase diagram that I've got a column finished here that I can add down. So I'll add my 80.4 and my 171, and I'll get 251.4 for my total weight here. We'll make that number 9. 251.4. And always remember when you're doing these just to go ahead and write down these steps. Just kind of helps you keep track of things. And it's also going to help me when I'm grading the final exam to see where you got answers from. Even if you don't plug all the numbers here, you're kind of showing me what process you would have gone through to solve for these different things. All right, so now I know all of this information. I can solve for different things here. I'm going to go ahead and solve for this volume of water since I know the weight of the water and the gamma water here. And I'll make that number 10. So my volume of the water, and remember you've always got the relationship right up here that you can use. It's going to be my weight of the water divided by my gamma water. And in this case, my weight of water is 80.4 and my gamma of water is 62.4. So 80.4 pounds over 62.4 pounds per cubic foot. And I'll go ahead and put that in my calculator. 80.4 divided by 62.4. And I get this nice long thing. I'll just round it to the hundredths place, 1.29. And remember, my pounds will cancel out here. my cubic feet are in the denominator of the denominator, so they become my unit. 1.29 cubic feet. Now I'll go ahead and write that for 11 too, because I'll just duplicate it. I need to write that 1.29. And I guess the question is, how am I knowing to duplicate that? Well, remember, if I go back to my initial problem statement, it says that everything is saturated. Remember, we're all below a body of water. So my volume of voids is going to equal my volume of water. Whoops. Because it's saturated. Okay, so give a little justification for that. And so that will be, whoops, I meant to make this 10 and so that this is 11, 1.29. And if I know that's true, I can go ahead and fill out that volume of air too, because if those two are equal, that has to be equal to 0. Okay, and there's a lot of different ways I can justify that, but I'll just say that my volume of voids equals volume of water plus volume of air. And so therefore my volume of air is 0, because those two are equal, because it's saturated. So kind of a circular argument there. All right, now I can just look and add up my columns here. I'm just going to go straight on down for my total volume here for 13. So that's just going to be 2.29, and then I'll duplicate it here for 14, 2.29. So I'll put that here. That 13 is going to be my volume of the voids plus my volume of water, which is 2.29. And then for 14, I'm going to duplicate that V. Okay, and that leaves me with 15, which is what I was looking for all along. I want to find this total gamma, and so the way I can find that is to take this weight, total weight, and divide it by the total volume. So I'm going to go ahead and write that equation here, weight over volume. I'm going to go ahead and do that in my calculator. 251.4 divided by 2.29. And I get 109.78. I'm going to go ahead and round that up to 109.8. And that will be my number 15. And I'll put it on my steps here. 109.8 pounds per cubic foot. Okay, so all that work, and I just found the gamma clay that I can put into my soil profile. So I'm going to go ahead and put this stuff to the side and go ahead and try to draw a profile of what this problem is asking me, because now I'm ready to think about my vertical effective stress. So remember, it's a surface of a saturated clay deposited below a body of water, below a lake. So I'm going to go ahead and put my lake up here and put my clay down here. Okay, so here's my clay and here's my lake. We know that we actually don't know exactly how deep the clay layer is, but we know we want to look at the effective stress at this point A, which is 37 feet below the surface of the clay layer. Now remember from problem 2 that this water at the top, when we're talking about effective stress, we know that that water is not going to be part of it because that's going to have to be subtracted out. So in order to figure out the total effective stress for this problem, all we're going to need to do is to look at this clay layer. It's really just this part here, and I figured out my gamma clay, and I'm going to have to subtract a gamma water from it and then multiply it by either the depth that I'm interested in or the strata, because all this tells me is that it's 37 feet below the top of the layer, and that's the only layer that is really there. That's all I have to multiply it by. And so I go back to my phase diagram and I remember that this is 109.8 pounds per cubic foot minus 62.4 pounds per cubic foot, and I'm multiplying that by 37 feet. And I put that in my calculator. 109.8 minus 62.4 get that answer, and then multiply that by 37, and that gives me 1,753.8 pounds per square foot, and that's going to be my vertical effective stress at this point, 37 feet into the clay layer beneath the lake. So kind of neat. You have to put all that stuff together that you've learned before. You've got your phase diagram work, your steps, and that gives you the information that you can then put in and figure out the vertical effective stress.